Hello, my name's Dr. Greg Brown, one of the astronomers here at the Royal Observatory, Greenwich. Our night sky is absolutely filled with stars. Using powerful telescopes, we can see that the universe is filled with vast collections of stars called galaxies, these cities of stars in the void of otherwise empty space. But we also know that our universe was not always this way. About 14 billion years ago, our universe began in an event called the Big Bang. At this time, our universe was a super dense, super hot lump. The Big Bang began the expansion of the universe. The material in it began to spread out and cool down. After a long period of darkness called the Cosmic Dark Ages, eventually the material cooled down enough to clump together and begin to form the first stars. These stars were huge, many times larger than our own sun. They were also exceptionally hot and very short-lived, much shorter than most of the stars that exist in the universe today. An ongoing part of astronomy research has been to try to find these first stars. Unfortunately, things are working against us. For one thing, the light from these stars is no longer in the visible range that our eyes can see. It's instead in radio light. It's been stretched out by the expansion of the universe. Also, our own galaxy is working against us. The signal coming from these stars is about 1/10,000th the noise coming from our own galaxy. And yet, despite the odds, it seems that astronomers led by Judd Bowman of Arizona State University may have found the signal of these elusive first stars. The signal itself is a slight absorption, a slight dip in radio light that's associated with hydrogen gas, the most common element in the universe. Interestingly, the signal that they found was much stronger than they expected, indicating that the hydrogen gas was absorbing more light than we expected it to, which means that the hydrogen gas must have been colder than we expected it to be. So how did the universe cool down this quickly? Well, one astronomer, Renan Barkana of Tel Aviv University, suggests that it might be an interaction between this hydrogen gas in the early universe and something called dark matter. Dark matter is a very elusive, very unusual, enigmatic substance that nonetheless makes up 80% of all of the stuff, all of the matter in our universe. Unfortunately, we have no idea what it's made out of. This observation, though, suggests that the particles of dark matter must be much smaller than initial models suggested. So maybe with a few more detections and a few more discoveries like this, we'll finally find out what dark matter is. But don't worry if you're wondering if we're running out of questions to ask in astronomy. The vast majority of the energy of the universe is in something called dark energy, and we have absolutely no idea what that is. Thanks for listening.